Welcome to the Big Bear Math Channel and our 5-minute video, part 3 of 3 on integration by U-substitution. In the next 5 minutes, we're going to focus on integrals that have an e in them and letting u equal the exponent. And we're going to cover exactly what you need to know in order to get that 5 on the AP Calculus exam. So, let's go tackle some bears. Here's a real quick recap of the 3 scenarios you'll see on the AP exam and where the other videos came from. On that first video, we talked about letting u equal the inner function. On the second video, we talked about letting u equal the denominator. So we said if you're integrating a fraction, there's a really good chance you're going to want to let u equal the denominator. And in today's video, we're going to focus on, well, the common theme is that we're going to see e's in all the problems, and we're going to let u equal the exponent. So here's a real brief warm-up to kind of set the tone for what we're about to see. And go back to your derivative days and ask yourself, how would I have derived something like e raised to the u power, where u represents some function of x, basically anything you can imagine that's in terms of x. Well, what it would be is you'd take the original function and multiply by the derivative of u, or the derivative of the exponent, and the product of those two things would be your derivative. Well, today we're going to do just the opposite. We're going to integrate e to the u times du, and the antiderivative is going to simply be e to the u plus c. So it's probably one of the best integrals ever. You really don't have to memorize anything fancy or obscure. It's just the antiderivative of e to the u is simply e to the u. So you might have derived something like y equals e to the x squared plus 1 power. And we would have said that function's derivative is e to the x squared plus 1 power times 2x. Well, today, imagine yourself doing just the opposite. What if we wanted to integrate e to the x squared plus 1 times 2x with respect to x? And we're going to show you how to get an antiderivative of e to the x squared plus 1 power plus c. Alright, it's finally time to tackle a real live example here today. And just quick recap, and you saw the same statement in the earlier 2 videos. Our main goal on all U-sub problems is to rewrite the entire integral in terms of u. And basically what we want to do is we want to get rid of all of the x's. So as soon as you see that problem and you see an integral working with an e, we're going to let u equal the exponent. And what we're going to do is we're going to derive both sides with respect to x. So you'll see a lot of common themes, the derivative of u with respect to x. You'll see a lot of common themes with all of our U-sub problems. They have a lot of common elements tailored to them. I'm going to multiply the dx to the other side, and then we'll divide both sides by 2x. In other words, we're isolating that dx right there and getting it totally by itself. And now we're ready to make some substitutions. I'm going to substitute the u in for the exponent right there, and then I'm going to substitute the du over 2x in for the dx. And here's what it would look like now. That first term is still an x. We now have e raised to the u, and we have a du divided by 2x. And here's the most exciting part. These x's are going to cancel out. And now we have successfully gotten rid of all of the x's, and we have rewritten the entire integral in terms of u, which was our one big goal. So let's just rewrite it so it looks a little cleaner. I'm going to pull out, I've got a coefficient of 1/2, and it's always a good idea to put that out in front of the integral so that we don't lose it. And we've got e to the u times du. And let's see, the coefficient's simply going to come along for the ride, and the antiderivative of e to the u du is simply e to the u. We'll throw on our plus c. And one last move, we're going to rewrite it in terms of x. You always if the original problem's in terms of x, we want to present our answer also in terms of x. And this, ladies and gentlemen, is my antiderivative. So if you're looking for more examples, feel free to search through the Big Bear channel and look for integration of e's or just any kind of integration by U-sub, and I'm sure you'll find some more great examples with a similar verbiage and process.